Hi, this is Mrs. LaBarbara. This is AP Physics Mechanics C. Today I want to go over an example of force and energy. So the variable x represents the position of particle A in a two-particle system. Particle B remains at rest. The graph shows the potential energy Ux of the system as a function of position x of particle A, which has a mass 0.4 kg. Particle A is released from rest at position x equals to 2 meter. Assume positive to be toward the right. Part A. Calculate speed of particle A when it reaches position x equals to 40 meter. So this is energy conservation problem. So position 1, total energy equals to position 2's total energy. U1 plus K1 equals U2 plus K2. U1 we know is 8 joules. K1 equals to 0 because it is starting from rest. U2 we know is 6 joules from the graph. So we need to find K2, which is 1/2 mv squared. So from that equation we can find V. V equals to 3.16 meter per second. B1. Calculate magnitude acceleration of particle A when it reaches position at x equals to 3. X equals to 3 is right over here. So what is the acceleration? So here is Ux graph. From Ux graph we can find force. Force is the negative slope because force equals negative du dx, and du dx is the slope. Force is negative slope. What is the slope? Slope is 12 divided by 6. Negative 2. So the force is 2. F also equals ma. We know what m is, 0.4. So we can find out A, which is 5 meters per second squared. Part B. What is the direction of the acceleration of particle A when it reaches position x equals to 3 meters? Acceleration is positive. What's positive? Positive to be toward the right. So the acceleration has to be going to the right. Part C. Determine the magnitude acceleration of particle A when it reaches position at x equals to 7. Look at x equals to 7, slope equals to 0. So there is no force. If there is no force, there is no acceleration. Acceleration is just 0. Part D. Particle A is again released from rest at position x equals to 2 meter. Calculate elapsed time for the particle A to travel from x equals to 2 to x equals to 6. So from 2 to 6, what do we know? We know initial velocity is 0. We also know the displacement is 4 meters. We also know the acceleration is positive 5. Those are the quantities we know. We have to find t. Now we have to use kinematics. So we can use this equation, d equals vit plus 1/2 at squared. We know initial velocity equals to 0, so first term becomes 0. You find t equals to square root of 2d over a. Substitute the numbers, you'll have t equals to 1.26 seconds. D part 2. Calculate elapsed time for the particle A to travel from 6 meters to 8 meters. So we know this distance. If we know the speed at 6, and we know the speed doesn't change during 6 meters to 8 meters, we can find the time. We can find the speed at 6 meters because we know a lot of things. We know the initial velocity here, we know acceleration, we know the final velocity. We know the acceleration, we know the time. So we can just use this equation to find the final velocity at x equals to 6. Vi in this case is 0, a is 5, and t from 2 to 6, it takes 1.26 seconds. So we have Vf. That is the velocity at x equals to 6 meters. We also know the total distance is 2, so we can figure out the time. So time is 0.32 seconds. By the way, d equals to, v equals to d over t, so t equals to d over v. D3. Calculated the time for A to travel from 8 meters to 14 meters, from 8 to 14. So again, let's see, we know the velocity at 6. Velocity at 80 is the same thing. We also know the speed at 14, actually. The speed at 14, that's the part we solved in part A. So we know initial speed, we know final speed, we can find average speed. We also know the distance, so we can find time that way. We know initial speed is 6.32. We know final speed is 3.16. So we can find average speed. Initial plus final divided by 2. Average speed is 4.74 meters per second. We know the distance is 6 meters, which is 14 minus 8. So what's the total time? D over T. T equals D divided by V. D is 6. And average speed is 4.74. So T, the time period is 1.26 seconds. Next one, particle A is now placed at position x equals to 7 meters. For the particle A to reach position x equals to 60 meters and to be moving at 1 meters per second, what is the initial speed the particle must have, particle A, to be given at this position? So we can use energy conservation. At this position, U1 plus K1 equals U2 plus K2. By the way, this A should be capital A. So U1 equals 0, K1 is the one we don't know, 1/2 0.4 times V squared. We know over here the potential is 6, and its kinetic is 1/2 times 0.4 times 1 squared. So from here we can solve for V. V, the speed it must have 5.57 meters per second in order to reach this position with 1 meter per second. Last part, on the grid below, carefully draw a graph of the force F acting on the particle A as a function of x for the range of 0 to 60 meters. So here is the graph of U versus x. We need to, from U versus x, to find F versus x. So again, F is negative slope. So we just have to find the slope and negate it to find F. So the slope from 0 to 6, the slope is negative 2. Therefore, F is positive 2, constant. The slope between 6 to 8 is 0. So F has to be 0. The slope between 8 and 14 is positive 1. So F has to be negative 1. Again, the slope between 14 and 16 is 0. So your F has to be 0. So then you're kind of like connecting between the period. And that's it. Thanks for watching. See you next time.